Hi, my name is Rodrigo.
Hi, my name is Fernando.
We will be doing a review of Chapter 7, Transportation Layer, of Cisco CNA. The transport layer is responsible for establishing a temporary communication session between two more applications by a segmentation of data. It also takes the controls to reassemble the segments. In TCP/IP, this process is achieved by two protocols of this layer. Let's check each of these three points. The role of the transport layer. Tracking individual conversation. A host may have multiple applications that are communicating across the network simultaneously. The transport layer has the responsibility to maintain and track these multiple conversations, segmenting data and reassembled segments. Every network has a limitation on the amount of data that can be included in a single packet. It is why the data is encapsulated by this layer protocol to reach a specific size. Also, a header is included to reassemble the blocks of data into strings to be passed to the application layer. Identifying the applications. To pass data stream to the proper applications in the network, the transport layer assigns each application an identifier called a port number that is unique.
Conversation multiplexing. Conversation multiplexing led us to send and receive data from different applications, which is allowed by the segmentation of the data. The header of the segments brings values to perform different functions in managing data communication. Transport layer reliability. The transport layer is also responsible for managing reliability requirements for a conversation. The transport protocols TCP and UDP are used by the IP to enable hosts to communicate and transfer data. They specify how to transfer messages between hosts. Let's check the TCP. It's considered a reliable transport protocol because of its three basic operations, which are tracking transmitted data segments, which are numbered in sequence, acknowledging received data, the sender must receive and acknowledge. If the sender does not receive an acknowledgement within a certain period of time, the data is retransmitted. All this control information is contained in the TCP header. Some examples that use this protocol are the File Transfer Protocol, FTP, and the Hypertext Transfer Protocol, HTTP. This protocol is better choice for applications such as databases, web browsers, and email clients. Required that all data that is sent arrives at destination in its original condition. Some TCP features are connection-oriented conversation by establishing sessions in order to ensure that the application is ready to receive the data. Reliable delivery. All the data is received. Order data reconstruction. The segments are reassembled into the proper order. And flow control. If the resources are overtaxed, TCP can request that the sending application reduce the rate of data flow. A TCP segment header is confirmed by sequence number, used for data reassemble purposes. Acknowledgement number indicates the data that has been received. Header length, known as data offset, indicates the length of the TCP segment header. Reserved. This field is reserved for the future. Control bits includes bits, codes, or flags that indicate the purpose and function of the TCP segment. Window size indicates the number of segments that can be accepted at one time. Checksum, used for error checking of the segment header and data. Urgent indicates if the data is urgent. Now, UDP. The UDP provides basic functions for delivery because there is no acknowledgement that the data is received at the destination. Now, UDP. The UDP provides basic functions for delivery because there is no acknowledgement that data is received at the destination. The sender of the letter is not aware of whether a receiver is available to receive the letter, nor is the post office responsible for tracking the letter or informing the sender if the letter does not arrive at the final destination. This protocol is a better choice for an application that can tolerate some data loss during transmission, like streaming audio or video. The UDP features are connectionless, no session establishment, unreliable delivery, the lost data is not resent, no ordered data reconstruction, data is reconstructed in order that is received, no flow control, there is no congestion management. The pieces of the communicating in UDP are called datagrams. Only few applications that use UDP are domain name system, DNS, video streaming, and voice over IP. TCP and UDP port addressing. When a message is delivered using either TCP or UDP, the protocols and services requested are identified by port number. By sending and receiving a port number, a communication can be tracked by the transport layer. The source and destination ports are placed within the segment. The segments are then encapsulated within an IP packet. The IP packet contains the IP address of the source and destination. The combination of the source and destination IP addresses and the source and destination port numbers is known as a socket. The socket is used to identify the servers and service being requested. The sockets are conformed by the IP addresses plus the port number. Here is an example. The Internet Assigned Numbers Authority, IANA, assigns port numbers. There are three types of ports. Well-known ports. These numbers are reserved for services and applications. Registered ports. These port numbers are assigned to the user processors or applications. Dynamic or private ports, also known as ephemeral ports. These are usually assigned dynamic or private ports, also known as ephemeral ports. These are usually assigned dynamically to client applications when the client initiates a connection to a service. Netstat command. To know which active TCP connections are open and running on a network host, you can use the command netstat. Netstat should be used to examine the open connections on a host when performance appears to be compromised.
TCP response. The key distinction between TCP and UDP is reliability. The reliability of TCP communication is obtained through the use of connection-oriented sessions. before a host using TCP sends data to another host. TCP initiates a process to create a connection with the destination. When the source receives an acknowledgement, it knows that the data has been successfully delivered and can keep tracking that data. If the source does not receive an acknowledgement within a predetermined amount of time, it retransmits that data to the destination. Part of the additional overhead of using TCP is the network traffic generated by acknowledgements and retransmissions. Each application process running on the service is configured to use a port number either by default or manually by a system administrator. And an individual server cannot have two services assigned to the same port number within the same transport layer services. Establishment connection. Control bits in the TCP header indicate the progress and status of the connection. The three-way handshake are establish that the destination device is present on the network, verifies that the destination device has an active service and is accepting requests, informs the destination device that the source client intends to establish communication. Information used to manage the TCP processes are URG, urgent pointer field significant, ACK, acknowledgement field significant, PSH, push function, RST, reset the connection, SYN, synchronize sequence numbers, and FIN, no more data from sender. For Wireshark, we can divide that in 3 steps. The first step is TCP segment. In this frame shows SYN flag set to validate an initial sequence number. Randomized sequence valid number valid relative value is 0. And random source port 1061 is this one. Well-known destination port is HTTP port, indicate the web server. That one is this one. The step number 2. ACK flag set to indicate a valid acknowledgement number. Acknowledgement number responds to initial sequence number as a relative value of 1. And it's here in this segment. Destination port number of 1061 to corresponding to the client's source port number of 18 HTTP, indicating the web server service HTTP D. The number 3 or the step number 3 of Wireshark is finally the TCP client responds with a segment contains an ACK that is the response to the TCP SYN sent by the server. After both sessions are established between client and server, all additional segments exchanged in this communication will have the ACK flag set. You can add security to the data network. That one are these ones. Now for establishment, but now after look at Wireshark, we have also looked at that. We have to end each one-way TCP session. A two-way handshake is used consisting of a FIN segment and an ACK segment. Step 1 is when the client has no more data to send in the stream. it sends a segment with the FIN flag set. Step 2. The server sends an ACK to acknowledge the receipt of the FIN to terminate the session from client to server. Step 3. The server sends FIN to the client to terminate the server to client session. And then number 4 is that the client responds with an ACK to acknowledge the FIN from the server. TCP order data, because sometimes the router sends back the data or the information, and then the computer have to reorder the data. And for example, in this image, we can see that segment 1 is the first one, segment 2 is the second, segment 6 is the third one, segment 5 is the fourth one, segment 4 is the fifth one, and the fifth one, and the segment 3 is the last one. And then they have to reorder the TCP, or well, not the TCP, the information. When services send data using TCP, segments may arrive at their destination out of order. For the original message to be understood by the recipient, that the data in this segment is reassembled into the original order. Sequence numbers are assigned in the header of each packet to achieve its goal. ISN, initial sequence number, represents the starting value for the bytes for this session that is transmitted to the receiving application. Acknowledgement segment. The sequence SEQ number is an acknowledgement number, ACK, are used together to confirm receipt of the bytes of data contained in the transmit segment. The SIQ number indicates the relative number of bytes that have been transmitted in this session, including the bytes in the current segment. TCP uses the ACK number sent back to the source to indicate the next byte that the receiver expects to receive. This is called expectational acknowledgement. In other words, we can say that the data of the second device receives the information of the first device, and the second device have to send a message to the first device that the second device receives the information. Because if the second device don't do that, the first device will think that it couldn't send information, so it will try. The first device will try again. Handling segments lost. For checking if the data has received, the first device which sent a packet of a bit data has a timer. It means that if after a certain time the other device don't resend another package which says that it received the information, the first device will believe that the second device didn't receive the data, and it will reset the bit of data. QDP data transport. QDP is a simple protocol that provides the basic transport layer functions. It has much lower overhead than TCP because it is not connection oriented and does not offer the sophisticated retransmission, sequencing, and flow control mechanisms that provide reliability. QDP includes Domain Name System (DNS), Simple Network Management Protocol (CNMP), Dynamic Host Configuration Protocol (DHCP), Routing Information Protocol (RIP), Trivial File Transfer Protocol (TFTP), IP Telephony or Voice over IP (VoIP), and also online games. Because UDP is connectionless, sessions are not established before communication takes place, as they are with TCP/UDP is CSP transaction based. That is, when an application has data to send, it simply sends the data. Many applications that use UDP send small amounts of data that can fit in one segment. Therefore, UDP simply resembles the data in the order that it was received and forwards it to the application. When UDP receives a datagram destined for one of these ports, it forwards the application data to the appropriate application based on its port number. In this case, the port is 1812, the radius. And the DNS request will be received on port 53. Response sources of an UDP. As with TCP client-server communication is initiated by a client application that requests data from a server process. The UDP client process randomly selects a port number from the range of dynamic port numbers and uses this as the source port. For the conversation, the destination port is usually the well-known or registered port number assigned to the server process. After a client has selected the source and destination ports, the same pair of ports is used in the header of all datagrams used in the transaction. For the data returned to the client from the server, the source and destination port numbers in the datagram header are reversed, and it doesn't send the information. Applications for the TCP. Some examples of well-known applications of TCP include Hypertext Transfer Protocol, that is the HTTP, File Transfer Protocol, FTP, Simple Mail Transfer Protocol, SMTP, and the last one is the Telnet. For the applications for UDP, there are three types of applications that are best suited for UDP. Applications that can control some data loss but require little or no delay. Applications with simple request and replay transactions. Unidirectional communications where reliability is not required or can be handled by the application. Some examples are DHCP, DNS, CSNMP, TFTP, VoIP, and IPTV. Thank you.